So that time these will be playing very important role. It is all our responsibilities to understand basic materials, what all these materials and where these limited applications have, we can have to understand them. And you can see that in the engineering and technology, already we know the basic manufacturing process and secondary manufacturing process. The primary manufacturing process is that extraction of the ores, and we are going to do some kind of compositions of the materials to the requirement. That is the one part. The second part is physically to get some particular shape of the object. We need to combine different parts together to make integrated a single one, so that for the functionality it will be helpful. So those kind of secondary manufacturing processes will be by means of welding, by means of brazing and soldering, and so many other processes. Okay, these are the other things. And you can see that daily while you are walking on the road, you can find so many articles, so many things. Those all will be engineering materials, including the soil to the metals, whatever physically you can able to see them. Those are all the engineering materials. And you can see that the aircraft is not a simple thing. It is made out of a cover. The cover is made out of a composite materials, and the gears and the gearbox and the turbines, all these will be the costlier materials like tungsten, carbon and the steel, okay, titanium, and so many other the materials which still many people are working on the different compositions in the research field. Okay, and you can see the shipbuilding and the construction materials, all these are the engineering materials. And the earth crust have the enormous range of materials which is having in its crust, and it serves the human being as per the requirement, will be extracting them and shaping them. Okay, all these materials will be having their specific applications. Their applications will be there. Based on the applications, directly the extracted ore cannot be used. The extracted ore will be mixed with some other things, so that we'll be getting the different properties. Very simple example, in the previous class I told you, the aluminum is having the temperature of, it is a non-ferrous element. It is non-ferrous metal. Non-ferrous metal is one which will not be having the carbon in its. Okay, the non-ferrous materials, those will be having very lesser melting point, around 700 degrees centigrade, and they'll be light in weight, and they are not corrosive. Corrosion in the sense, when we are going to leave it to the atmosphere, the oxygen and the mist will be forming a layer of corrosion that will be corroding the part, and that will not be advisable to have it because it will be weakening the material. Such non-ferrous materials having the low temperature of melting, just like aluminum, which you are going to use it for the construction of the engines. You can see that the engine temperature is more than 3000 degrees centigrade. The melting point of aluminum is only 600 to 650 degrees centigrade. If you are going to make a alloy of aluminum, mixing with some zinc and silicon and carbon and some other elements, which will be increasing the other properties, like the melting temperature can be increased. The aluminum alone will be melting at 650 degrees centigrade. But if you are going to mix or make an alloy, it can withstand the temperature up to 3500 degrees centigrade with lesser weight. And the corrosiveness also can be improved. The wearness also, the wear, if you are going to take the aluminum and rub it together, within a matter of the 5 minutes, you will be losing around few grams. But here you can see that the piston is sliding in the cylinder, and every minute there will be more than 3,000 times it will be reciprocating inside. Such a high speed, high temperature, high pressure, it has to withstand, then it is possibly made out of the aluminums of alloys. Like that, the engineering family have taken a lot of lead in the research activities in order to make a special type of materials which can serve the human being. Okay, in the other hand, for the fabrication process, for the fabrication we are going to use the brazing and welding and soldering, depend on the requirement we are going to make the shapes. That is other hand. So the primary manufacturing process, the secondary manufacturing process. The primary manufacturing process is that we are going to make them out directly by using the machines. By using the machines, we are going to make them out. Just like you are going to use a forging machine for the component directly, you are going to create the component. Okay, that is one. And we are going to use the hot forging, cold forging. We are going to use the extrusion operations. You are going to make the aluminum wires by means of a block of aluminum in the hot conditions. That will be a primary extrusion method. The secondary one is that by making a permanent or semi-permanent or the temporary joint, we are going to make it to a requirement in order to serve the requirement. Okay, these are the simple introduction to the things. And before I get into the application part of it, one has to understand some of the important techniques or important terms which you are going to come across in them. Elastic property. I don't want to understand in depth the theory of elasticity. One very big the book itself is there, and theory of plasticity book is there, and theory of ductility book is there, malleability. All these are the different terms which you are going to come across. Try to understand the cover of it or meaning of it. Okay, and often frequently will be coming across the elastic property. The elastic property in the sense you can see that you have a rubber. You are going to stretch it and you leave it. It will come back to its own shape. Balloon, it is having its elastic property. And gold, you can see that gold, you are going to make a hammering and you can get into a thin sheet. And another one, the wire, you are going to make it, extrude it to a very thin wire. That is ductility, ductile. Okay, malleability, it is you can able to make into a thin sheet. Okay, hardness is a property. Other one, the hardness in the sense you can see that diamond is the hardest material in the world. Diamond can cut anything else. Okay, the diamond is having the hard property because it is having the maximum carbon content in it. It is a carbon itself, the diamond. Okay, the hardness will come across, the malleability will come across, the ductility will come across, elasticity will come across. All these are the different properties of the engineering materials. I don't want you to understand the definition of them, but try to understand what these are. Basically, the engineering materials are classified into 4 important groups. Whatever the material we are going to look into, all these materials will be falling under these 4 important groups. Metals and their alloys. Metals. The metals are those we are extracting from the earth crust, and these directly cannot be used. These will be mixed with some of the other metals in order to achieve the required properties like elastic property, hardness, ductility, malleability, toughness. All these are the different properties we expect from the metals for the different applications. For all these, directly the metal which are available in the earth crust cannot be directly used them. Okay, we cannot use them directly for the special applications. So all these will be with the required proportion. These will be mixed together to form the alloys. So the metals and the alloys. Okay, and the ceramics. These can able to withstand very high temperature. Just I'm giving the introduction. We can able to withstand the high temperature. Okay, even you are going to melt the metal, those metals will be melted in the crucibles of ceramics. Those can withstand temperature up to 6,000 degrees centigrade. We can melt the metal inside them. And the polymers, thermosetting and thermoplastic. The plastic, all these plastics are there. No, you can find the decorative plastic materials. Daily life, you are going to use the plastic bags. Okay, plastic covers. All these will be polymers. And the other one, the composite. These are non-metallic. The composites are those by layering technique we are going to make them up, and it will be very light in weight. You have heard of light combat aircraft, LCA. Our Indian defense, it has already LCA is serving the Indian defense. Its cover, no, its cover is made out of the composite materials. Like that, today we can find the composite gears also we can find. Okay, we can find composite gears. Today the world is filled with the composite materials because they are light in weight. They can able to serve the requirement and their weight is very light. You can able to hear me? Please don't talk in between. If any doubts are there, you can talk to me. Please mute your mic. Please mute your mic. The composite materials, you can see that the aircraft broad is a single person can able to lift it, so light in weight. But they have very good properties as of the metals. They have very good toughness. They can able to, they will be durable and they will not be reacting with the high temperature and high pressure, the humidity, the rain. All these are the basic important requirement. So those we can find in the composite materials also. So please understand basic 4 classifications of the engineering materials: metals and their alloys, ceramics, polymers, and the composite metals. And metals are again classified into 2 types: ferrous metals and non-ferrous metals. The ferrous, they have the carbon content in them. Non-ferrous, that doesn't have the carbon content in them. So likely the ferrous metals and their alloys and the non-ferrous metals and their alloys. We can see them later. Okay. Metals, you can see them. Iron and steels. Iron and steels are the metals. And these iron and steels, again metals, as I just know, I told you, ferrous and non-ferrous metals we can find. Okay. And the purpose of them, I think it is not possible to understand their specific applications, where exactly they'll be using. In a single day, it is not possible to understand them. Many are doing the investigation on the materials to the requirement, to suit the requirement. You can see that the turbine, the blades will be subjected to various temperature. They have to withstand very high temperature and they'll be rotating at very high speed. The turbine speed, axle speed will be more than 32,000 RPM. In a minute, they'll be rotating at 32,000 RPM. You cannot imagine. And how the bearing should be, how the material should be. There should not be any failure. You can imagine what kind of material they are going to use them there. Okay, like that. So each and every materials have their own specific applications. Our engineering fraternity, they have to find out their properties and to suit the requirement, we have to use them. And on the other hand, the ceramics, as I told you, they are made out of metals and non-metals. Okay, they are made out of metals and non-metals. They'll be mixed together to the required proportion, and